So, as we're saying, actually, if you look at this integral here, what we can do to make things easier was to have opened up this bracket. We are going to have 1 over 4, the phi here of 0 to 2 pi, then minus of another 1 over 4, 0 to 2 pi of cos squared 2 phi, cos squared 2 phi d phi. And if you consider that, of course, it was for the sake of this particular integral here that we are making this conversion. I was saying cos squared 2 phi is the same thing as 1 over 2 plus, open bracket, 1 plus this, cos 2 times 2 phi. You can just take note of this by calling 2 phi some theta, but in the end, you know that theta is equal to 2 phi, so that what you get actually is this. Now, looking at the integral here, integral of 0 to 2 pi of the phi is just going to give us phi, which ranges from 0 to 2 pi. In the end, it will be 2 pi minus 0, so and what we get is just 2 pi. So, and of course, the 1 over 4 is following it, so we have 1 over 4, 2 pi, minus, excuse me, I have here minus 1 over 4, but then again, in the conversion of writing this into another form, I have a 1 over 2 here, so which makes it minus 1 over 8, but then this is now what replaces cos squared 2 phi. So what we have is this replacing that, and this is what we get. And if we were to integrate this, of course, what we are going to get is some phi plus sine 4 pi over 4, integral again of 0 to 2 pi. You can see that that will be equal to 2 pi. Because sine 2 pi, or integral multiple of the pi, will be 0, and sine 0 is 0, and phi here, so if you substitute phi for 0, it's just 0. And so all you get is 2 pi. So in essence, I get a 2 pi over 4, which is just pi over 2. And then I get here another here 2 pi over 8, which is just pi over 4. So pi over 2 minus pi over 4 gives us simply pi over 4 here. So the integral, which is this, or by the way, which is what we have here, is what we started with, gives us simply pi over 4. And if you recall, we got that from this place. So this factor gives us 16 over 15. This gives us pi over 4. And so what we get in the end is 4 pi over 15. So you can see that this indeed gives us 4 pi over 15. You can take my word for it again as usual, or feel free to show that this squared d omega is also the same thing as n sub 2 squared, n3 squared d omega is equal to the same 4 pi all over 15, just like this one. And we have, of course, shown that the other variants in which we don't have them in this form is going to give us 0. So you can just do this one like we've done the first one, and you'll see that that is the case. And that, of course, brings us here. That completely proves this one. So it has shown us indeed that when any two of these, such that we will have them to be squared as detected by these conical deltas. And remember, for instance, like I said, if you were to choose this pairing, it will mean that I is equal to m. And that means I is not equal to iota and I is not equal to j. So each and every one of these is 0. So it's just one at a time, and that is why it's equal to 4 pi over 15 times the rest of this. Now what we want to do is just to illustrate an application of this in analysis. I'm calling out here a simple example from Wemberg's book. And this integral here we want to show is equal to that, whereby this object pi sub ij comma iota m is equal to that. So we just want to see indeed that when we use these results, we obtain this to be equal to that. Okay. So we want to perform the integral of I was contemplating which to write first, and that happened. Okay, so ij comma iota m of n hat, and n hat, by the way, is given by that. So I'm going to go straight forward into saying that this is the same thing as some chronicle delta I iota chronicle delta jm integral of d omega minus 2 times some chronicle delta iota, I, that, and then this is, of course, n sub j, n sub m, d omega, and that is the second term. Now the next term will be plus half the integral of all 4 objects n sub I, n sub j, n sub iota, n sub m, oh, the omega, sorry about that. Okay, now the next thing would be minus half chronicle deltas ij, chronicle deltas this, integral of the omega, then plus here, I have chronicle delta ij, integral of this, iota m, this, and then the last term I believe is going to be plus 1 over 2 chronicle delta iota m, integral of n sub I, n sub j, and the omega. Of course, just take a look at this term. You can see that what I left inside the integral sign, that's when you take the whole of this and substitute for this, what has been inside the integral sign have always been just the unit vectors. Every such factor as 1 over 2 and this chronicle delta stay outside the integral. For this, in fact, we didn't have any other factor but just the chronicle deltas, and that is why the integral is simply just the omega here. Well, one thing we may have to do shortly is to calculate this, which, as we said, is this 0 to 2 pi of sine theta, the phi, eventually, because that is what omega is. And so this, for instance, is the same thing as 0 to pi of sine theta, the theta, 0 to 2 pi of just the phi. Yeah. This, of course, becomes minus cos theta, 0 to pi, and then this gives us simply phi of 0 to 2 pi. And of course, as usual, I can pull out that minus sign, and then I have here 0 to pi, and this will simply give me 2 pi because it will be 2 pi minus 0. Minus 1 is minus 2, times this one here is just 2, so this is 4 pi. In essence, we are going to bear it in mind that the integral of this, or maybe I should just put that here for instance so that I won't have to. That integral is equal to 4 pi. So in other words, we have another 4 pi here. And wherever else it has occurred, well, I think that is all. Okay. Having done that, we just simply have to copy the results we've obtained. I don't need to do anything else, but just take note of what this will be from the hard work we've performed in the past few minutes. And this is going to give me here 4 pi of chronicle delta I iota Jm, and then this is going to be minus 2 times I iota. But this, of course, if you recall, will be 4 pi all over 3 chronicle delta, but Jm. If you recall, this is the integral here that we have shown earlier, that integral of n sub I, n sub j, the omega is equal to 4 pi over 3 chronicle delta ij. So, but since what we have here in our own case is Jm, my chronicle delta is Jm. Next is going to be plus 1 all over 2. Again, now we will have to open a big bracket because if you recall, this result was 4 pi over 15, but the first two, I and J and iota, I think here you can see the interchange. And then, of course, it's exactly the same thing. I don't need to bother myself. It's exactly the same thing, I guess. All is exactly the same thing. So very easy, I simply copy out the result. That is 4 pi all over 15. And then I have here with me chronicle delta ij, chronicle delta here, I iota m plus chronicle delta iota l, chronicle delta here, jm, and then plus chronicle delta iota m plus, then of course that is j iota. And that is what we get for that one. And of course, here we already have this to be 4 pi. So the 4 pi divided by 2, for instance, gives us a 2 pi, but that will be minus 2 pi chronicle delta iota j, and this is that. And this, of course, is going to give me another one like this. So I'm going to have plus 1 all over 2. So let me take that one step at a time. This is iota m, I believe, and so this will be 4 pi all over 3 chronicle delta iota m. Okay. Now we can just try to collect like terms, especially of things that are common. I have here with me iota L, and Jm. So these are common. I can have this to mean 4 pi minus this, then times that will give me 8 pi all over 3. And they both have iota, I iota and Jm. Yes. And of course, let me combine these last two because you can see Ij, iota, M. Okay, so as it is now, yeah. We missed a term, though. I jumped one, as you can see. This was supposed to be minus that. I got a 4 pi here, and so that will give me minus 2 pi times this here. And of course, I erroneously thought that this was the last time, which, if you recall, this will be 1 over 2 chronicle delta ij, but then this will be 4 pi over 3 chronicle delta iota m. What I missed was this, which was supposed to be 1 over 2 chronicle delta I iota m. But then again, like we will always perform, you remember this will be equal to 4 pi over 3 chronicle delta ij. So in combining these terms, we have already combined these first two. Like we've said before, they had common factors in terms of the chronicle deltas. Incidentally, these last 3 terms also have common chronicle deltas. I have chronicle delta ij, iota m, iota m, iota m, ij. So in simply, this of course cancels that and gives me 2 pi over 3. I minus this one, 2 pi, and plus again another 2 pi over 3. So at this point in time, the next thing I'm simply going to do is, being confident with what we've done so far, we can erase this. And then, hope we wouldn't need anything there. At this point, we can see the first one here. We can simply combine them by saying here is going to give me some 12 pi minus that. I'm expecting a 4 pi all over 3 chronicle delta iota, I iota, and then this will be Jm. And the next one here is this plus this is going to be 4 pi over 3 minus 2 pi. And so that will give me some minus here. 4 pi minus 2 pi is going to give me 4 pi minus 6. Yes, so 4 pi minus 6, and that gives me minus 2 pi all over 3 chronicle delta iota m, and then chronicle delta ij. And if you look carefully, you can see that these factors here is sort of common. So one thing I've done is to have cancelled these two here. Evaluating this gives us 2 pi over 15. But if you look at these factors, for instance, this one here, I've just written that down. Let's just go straight forward and see what happens. But let's take note that this could be labeled as, I guess what I call that was 2. I am having 2 2's here. Please note this is 1. So this is 1. And then I'm calling this 2. So what I've got here, for instance, is maybe 2 pi all over 15. So I'm going to open up this bracket, ij, chronicle delta iota m, and this I have called factor 2. And then the next one is going to be plus 2 pi all over 15 chronicle delta I iota, chronicle delta Jm, and this factor I am going to call 1. And now, of course, the last term there is 2 pi all over 15 chronicle delta Im, and then chronicle delta J iota. And what will this give me? Now, if I combine these two, because of course they are equal, not equal, they have a common factor I iota Jm. So I'll simply have to add these two. This is going to be 5 times this, which is 20 minus that. So this gives me 16 pi all over 15 of chronicle delta iota L, and then this will be Jm. Now combining again the 2's, which is this and this, as you can see, I'm having a minus, so it will be 2 pi minus 10. And so if it is going to be 2 pi minus 10 of that, so it's going to be simply minus 8 pi all over 15, chronicle delta iota m and ij over there. Then of course this one here that I'm not combining with anything remains 2 pi all over 15, chronicle delta im and chronicle delta j iota. Of course, what I intend to pull out to see if this is all going to be equal is to try to pull out 2 pi all over, I'm going to try to pull out 2 pi all over 15. And with this then, it means then that I've made a mistake somewhere, and that is something I can simply figure out soon. This is 16 pi over 15, minus 8 pi over 15, equals 2 pi over 15. Okay. Yeah, so please, sorry, in combining these two terms, I erroneously assumed this was a minus. Of course, it was a plus all along, but so by the LCM, if you add these two terms, you're going to get, dividing this 15 by 3, you get a 5 times this gives you 20. So, of course, it will be 20 plus 2, that gives you 22 pi. So that in the end, what we have is, if I were to pull out a common factor of 2 pi over 15, this will be 2 pi over 15, and I'm going to have 11 here. No more pi, but chronicle delta I, iota, chronicle delta jm. Minus, because I pull out a 2, this could be 4. As a matter of fact, it should just be 4, because the pi has been taken out. Im. And then here, this will be simply plus Im and j iota. And if you look closely enough, you can see that this is indeed exactly the same thing as what we set out to prove. So these are very interesting sets of integrals. Like I told you before, I met this set in classical electrodynamics. It was quite funny indeed to see my frustration then, if you can imagine what it was for me. Well, but it just tells you how valuable this could be, and not just in classical electrodynamics. Now we're seeing it in gravitational wave theory. Yeah, eventually we are going to need these results later on in future. Thank you for being with me today.